Alright, so this is exam 3 review on mathematical modeling, and so we start here. It says let the total yearly enrollment E in millions of students at universities and colleges in America be a function of the years T since 1965. Alright, we're going to use the table below to answer the following problems. Alright, so here we have our time, and here we have our enrollment. Remember, T equals 0 corresponds to the year 1965, so T equal 10 is the year 1975, and so on. And so what we want to do here is first start out and answer the question of how many students were enrolled in 1985. So T, in this case, it starts in 65, so T is equal to 20. And we look at 20 and we see we have 12.247 million students. Okay, and we can plug this in functional notation. We can plug in 20, and then the output, of course, is 12.247. Okay, so on the next part, it says use linear interpolation to estimate the number of students enrolled in college in 1988. So first, 1988 corresponds to T equal, well, it starts in 65, so 10 gets me to 75, another 10 gets me to 85, and 3 more gets me to 88, so T is 23. And so what I want to do is approximate the enrollment after 23 years. Now 23 is right between these two points, and so the idea is you say, okay, if I was going to estimate it, a good estimate might be about 12.247. So you can say, 12.247, but it's going to be a little bit more. And to determine a little bit more, the idea is that there's 10 steps between 20 and 30, and I would like to create 10 steps between these two numbers, 12.247 and 14.261. The way we do this is we use the average rate of change. And so to calculate that, you take the change in the output, so 14.261, minus 12.247, and so that's how the students are changing from 20 years to 30 years, and then divide by the change in the input, so 30 minus 20. Right, so what this number will give us is millions of students per year. It'll tell us how the enrollment is changing student-wise per year, and we're going to multiply by 3 years because we're going from 20 to 23. And our answer will be, well, take out your calculator and we'll crunch this number. So you take 12.247 and we add left parenthesis 14.261 minus 12.247 right parenthesis divided by left parenthesis 30 minus 20 right parenthesis multiplied by 3, and out pops our answer of about 12.8512 million students. All right, so we have 12.8512 million students. And then in functional notation, this can be written as E of 23 is the input, and then approximately the output we found was 12.8512. Okay, on part C now, we're going to do something slightly different because it says use linear extrapolation to estimate the number of students that will be enrolled in 2010. So in 2010, right, we start again in 65, so 5 gets to 70, plus 30 to 2000, plus another 10, so that's 45 years after 1965. And so 45 is right down here. And it's extrapolation because we're going to estimate a value outside the table, where this one was interpolation, and we estimated a value inside the table. And the way we're going to do this is quite similar to what we did before, but instead of using these 2 points, we'll actually use these 2 points. And because it's outside the table, it's down here, we'll start with the 17.488. And then we'll add, and we figure out how the data is changing. So we find the average rate of change right here. So we take 17.488 minus 14.261. And we'll divide it by 40 minus 30. And so this tells us how the number of students are changing each year. And then we'll multiply by the number of years that we're going. So we're going from 40 to 45. So that's 5 years. We'll take out our calculator. And our calculator will do the same thing we did before. So 17.488 plus left parentheses 17.488 minus a 14.261, right parenthesis, divided by left parenthesis 40 minus 30, and then multiply that thing by 5. And we get out 19.1015. So this is 19.1015. And this is millions of students, so million students. The units are very important, so don't forget them. And then down here we can fill in the functional notation. So the input was 45, and it was approximately, right, since we estimated it using this linear extrapolation, it was 19.1015.